Use the given data to find a regression equation, the least squares line of best fit, that predicts an average Subaru Outback price based on its mileage. The regression equation for the linear regression is y hat equals a plus bx. Or you may see it in some books written as y hat equals b sub 0 plus b sub 1 x. The format is the same, however, whether you have b sub 0 as the y-intercept or a as the y-intercept. So let's look at that right away. This constant term, so y and x are the variables. Those represent the data, and then the predicted data, that's the y hat. And then these values that we will find for the regression equation. This constant term a, that's the y-intercept. That's where the line crosses the y-axis. So if x were set to 0, we would get just whatever this value of a is. The b then is the slope of the equation. And if you look at this from an algebra class, you would say, hey, this is out of order. Usually you write the slope times x and then plus the constant term, and that's true. In statistics, usually you write the y-intercept, the constant term, first. So the slope, how much this predicted value of y changes for every increment in change in x. Y hat then finally is the predicted value. And that's why it's got the y hat, predicted value, because you plug in some value for x, so some value of mileage, and then you'll get some predicted value, and it's an average predicted value. So here's all of our data, miles on all of these cars and their list prices. So what I'm going to do to find the equation, I'm going to use Excel, and I'm using Office XP, so if you have the older version, take heart that you have all of these features. And of course, if you have the newer version, then absolutely you have these features. They will look a little bit prettier probably. In a previous video, we found R, the coefficient of correlation, to be negative 0.876. So this is a pretty decent correlation, pretty strong correlation. Now, I'm going to choose all of the data first before I go to Chart Wizard. So I just click on all that, and in fact, what I like to do is start at the bottom. Seems to be work the fastest. And then I just scroll up. Now, I have got all of my data chosen. Then I'm going to click on Chart Wizard. And what do I want in the Chart Wizard? Well, I want the XY scatter plot. And I just double clicked on that. Let's go back to see what I did. I chose this chart subtype. Next. Make sure your data is in columns. Series is in columns here. Okay, and I'm going to go with next and just walk through some of these things. If you wanted to present this, we can say list price versus miles on the car. The x-axis is miles of the car. The y-axis is the list price. I'm going to get rid of this legend. I think it just takes up space. We know it. We only have one set of data here, just the miles and the list price. So we're not going to worry about the legend. Say next, and then where do I want this? I'm actually going to put this in a new sheet, as a new sheet, and then finish. And then we can see this, list price versus miles. Now it looks pretty small here, but you can see this definite trend on this scatter plot. As there are more miles, the list price goes down. Now, to find this equation, I'm going to right-click on the mouse on any one of these dots, and then add trend line. And Excel is pretty neat. It can do a lot of different regression equations. We are just doing the linear regression in this video. So I'm going to stay with the linear, and then I'm going to go to the Options tab. Don't mess with this stuff up here. Never ever change the y-intercept, because we want that to be true for whatever the equation gives us. Display the equation on the chart, And sometimes you do want the r squared. I'm going to leave it out this time because we've already found r. By the way, just to let you know, when it gives you r squared, you'll have to take the square root of that to get r. Or you can just use the Corel function as we did in another video in this series. Okay, display equation on the chart. Okay. It's very small down here. And if you were doing this on your own computer, of course, you would just see that equation and there would be no problem. I am going to just increase the font quite a bit so that you can see it. Okay, that looks better. Now, I want to write this down up here. So what we have for our predicted value is y hat equals, now I'm going to write this constant term first, the 24,478 minus 0.13, I'm just going to round there, 0.13x. And then let's talk about what this means. So this is the average new car price when there are 0 miles, because x represents miles. That's the average price of the new Subaru Outback. Of course, this data is a few years old. It's probably a little bit higher now. But now let's look at this slope. What does this slope mean? Well, if x represents miles, then this is saying on average now, the car goes down in value. It loses, and this is in dollars now, it loses 13 cents for every mile that is driven. So work that into your negotiations when you're trying to negotiate mileage paid from your boss. Try that. And I know that's already worked into the equation when they're paying you the miles. But anyway, that's what the slope represents. And in this case, it's negative, so you're talking about losing 13 cents for every mile that the car is driven.